Oh, hello everyone. This is Steve. I'm glad you're here. We're going to take this quadratic you see and we're going to graph the parabola that goes with it. So let's go ahead and get started. Got a 2 there in front of the x squared, positive number. Means this parabola is going to open up like this. And just like every other quadratic and parabola, our domain is going to be negative infinity to infinity. Let's find the vertex, everyone. To find the vertex, when we're in this form, we have to use this negative b over 2a formula. So let's see here, that's going to be negative 4 over 2 times 2, which is going to end up being negative 1. Remember, that's not your vertex, everyone. That's just the x value of the vertex. To find the y value, we actually have to take the negative 1 and plug it back into the original function. So 2 times negative 1 squared plus 4 times negative 1 minus 3. Watch those negative signs, and you crunch that out, you will get a negative 5. But that's just the y value of the vertex. You want the entire vertex, you got to go ahead and put those together in an ordered pair. Negative 1, negative 5. Once we get our vertex, we can get two other things pretty quickly. One of them is our axis of symmetry. The axis of symmetry is a vertical line. It's just x equals. X equals what? X equals the x value of the vertex, in this case, negative 1. The range we can also get, because I know this parabola opens up, so I know it's going to go up to infinity. And the lowest value it ever gets to is going to be the y value of the vertex. So this parabola will go all the way down to negative 5. So a range of negative 5 to infinity. Okay, we're going to need a y-intercept. Well, here's one of the payoffs of having the quadratic written in the form that it's written in. Y-intercept happens awfully fast because we just plug a 0 in for x, and it's going to zero out every term. That 2x squared is going to go away. That 4x is going to go away, and we're just going to be left with a negative 3. So our y-intercept, 0, negative 3. Well, I guess the only thing left to worry about now that I have my vertex right here, and I have my y-intercept right here, I know my domain, my range, my axis of symmetry, I got to see if there's any x-intercepts. So I've got to find the zeros of this thing. That's a little tricky. So let's try and find the zeros together. So we'll come down here. Zeros. Well, we got f of x equals 2x squared plus 4x minus 3. Let's use the quadratic formula. All right. Negative 4 plus or minus the square root of 4 squared minus 4 times a times c, make 2 and negative 3, all over 2 times 2, like that. All right, you do a little bit of simplifying, everyone. You're going to get negative 4 plus or minus the square root of 40 over 4. Don't try to cancel those 4's yet. 40 is the same thing as 4 times 10. And the square root of 4 is 2. So we can pull out a 2 in front like that. Split this up into two separate terms. This is messy, everyone. Do a little bit of simplifying. You get negative 1 plus or minus square root of 10 over 2. Do a little canceling of that second term. All right, now those are real numbers, everyone. Those are real numbers because I never took the square root of a negative. So they both correspond to x-intercepts. So I do have two x-intercepts, and they are at negative 1 plus square root of 10 over 2, comma 0, and negative 1 minus the square root of 10 over 2, comma 0. Now those are the exact x-intercepts, and if someone asks us for the x-intercepts, that's how we should give them to them. However, for the purpose of graphing them, it is worthwhile to use a calculator and observe that this number right here, this negative 1 plus the square root of 10 over 2, is approximately 0.58. And then this one right here, this negative 1 minus the square root of 10 over 2, is approximately negative 2.58. So that will help us draw our graph. So let's go ahead and go to our graph now. I think we have enough information to do it. Are you nervous about those nasty x-intercepts we found? Don't be, we'll take care of it. All right, let's get our vertex up here first. Negative 1, negative 5. 1, 2, 3, 4, 5, right down here. Is that right? 1, 2, 3, 4, 5, yes. Okay, our y-intercept is at 0, negative 3. And if we draw in our axis of symmetry, which I'm doing right now, you see this is at 0, negative 3 over here, but it should have a friend right on the other side at negative 2, negative 3. And while we're labeling things, let's go ahead and get that vertex labeled also. Okay, now we did have two x-intercepts, but they were these nasty irrational numbers, but they are roughly at 0.58 and negative 2.58. So check this out. 0.58 is right around there, and negative 2.58 is right around there. And you will notice, even though they're these nasty irrational numbers, they are still equal distance from the axis of symmetry, which is very, very cool. So our x-intercepts are on here, and the ordered pairs, remember those really nasty things with the square roots, right up there. But we use the decimal approximation, which we found on a calculator, to help us know where to put the points. And now we'll go ahead and connect our dots. Nice smooth curve, up like that. Nice smooth curve, up like that. And there's our parabola. So when you're drawing a parabola and you get some x-intercepts that are irrational, they still show up as x-intercepts on the graph, but sometimes it takes a little bit of work or maybe a calculator to approximate roughly where to put them. Okay, everyone, thanks for watching. I hope that helped.